So this question doesn't have the formula. Since the formula is not on your formula sheet, it would be built into the question. So the question would have started with compound interest formula is and we'll write it out again. A is the amount after t years. P is your principal. R is your interest rate, and it's written as a decimal. N is the number of compounding periods per year. And T is the number of years. So if you were given this question, all of this information would be given to you, which is nice, because in the past when it was on your formula sheet, you just got the formula and you had to remember what everything stood for, which isn't too hard, but it was a little bit more work. So now it'll be outlined what things are for, so now we just have to go and say, where does everything go into this, and figure out the question. So what we have, 4% interest compounded quarterly. When will it be 2,500? So when we put in all that information, we're wondering when the amount will be 2,500. We've got a principal amount of 1,500. Our interest rate was 4%, so we write that as a decimal. And it was compounded quarterly, so that's 4 times a year. And so we get this question. Now, our growth factor, if we simplify that inside the brackets, if I go 1 plus 0.04 divided by 4, this is the equation that I have. Now, what we learned yesterday was for solving exponential equations, we could solve them if we could get the bases to be the same. And so our base on the right is 1.01. First of all, did we make a powers chart for 1.01? No. So this is not going to be one that we're going to be able to solve without a calculator, because we're not going to get the bases to be the same on both sides. At this point, all we're going to be able to do with this one is solve it with our calculator. So we'll have to get our calculators out, and we're going to use that graphing calculator strategy where we put something into y1, something else into y2, and we're going to look to see where they intersect. So if I put 2,500 into y1 and 1,500, 1.01 to the power. Now, if you have a newer operating system where the power moves up like that, you can write 4x right up there. If your calculator is an older operating system that has the hat, you'll have to put the 4 and the x in brackets. Now, if you've got it on a standard window, when you hit graph, you should see the exponential graph maybe a bit, maybe nothing at all. All right. So One of the things that when using your graphing calculator, it's a very powerful tool, but it's not that you can use it without any mathematical knowledge. When we think about the graphs that we put in here, the first one, y1 equals 2,500. If you have y equals 2,500, what kind of graph is that? It's just a straight line, straight horizontal line going through 2,500. So as far as this graph goes, I'm going to need my window to at least see 2,500. I only go up to 10 for my y max. So I'm going to put in 3,000 just so that I can see that 2,500 line. And once we do that, our exponential graph is also showing up. Something about our exponential graph that I want to point out. So let's look at y2. Notice that there's a 1,500 in front. This 1,500 right here. What happens when t is 0? Okay? What does that number stand for? That's our principal. That's how much money you started with. That's how much you would have when t is 0. So it makes sense on our graph that that shows up as a y-intercept. That 1,500 is going to be our y-intercept. So that was why we couldn't see the red graph when we had our standard window from 0 to 10 either. Also, if you think mathematically, what happens when the exponent is 0? Any base to the power of 0 is 1. And so that 1 gets multiplied by that 1,500. So now just that little bit of knowledge of the 2,500, putting that into our graph, we can see most of the graph. You can also see that they don't quite intersect on our screen. So again, we're going to go to our window. We went up to 10. Doesn't look like we need that much more, but I'll go up to 20 to see what that looks like. And we're going to find out, do those two graphs intersect now? It's looking promising. And they do. So what we can do now is we can find that intersection by going second, calculate, number 5 where they intersect. To push enter 3 times, first curve, second curve, and your guess. And when x is 12.83. Well, I should make sure that x is what it was on my calculator screen, but in my formula I'm using t. T is approximately 12.83 years. So to the nearest quarter of a year, when will the amount be 2,500? Now, it's closer to 12.75, but at 12.75, it won't be at 2,500 yet. So it will only be at 2,500 after 13 years. So again, the compound interest formula won't be written in the questions, but you have it here in your notes. So you can do 12 and 13 as a practice, and I'll let you try some of those right now.